Good evening. I'm Satish here from Pragnan. So let us start Python programming from where we left in the last class. So in the last class, we had a basic introduction about Python and some of the basic components of the Python. Like we looked into uh, what is variables, identifiers, uh, literals, Python tokens, comments, and all basic thing about the Python we looked into. And another thing is actually before I start this actually I thought that I will go through some of the basic foundation of the computers. Maybe we may need this actually when we are trying to do these Python programming. But since you people are already in final year, so what I will do now, I won't be going in detail here. Usually, I take the classes for the first year onwards. No, so for them, they have not studied computer architecture, they have not studied operating system or those things. Like what I will do, I will just glance those concepts and then teach actually. Like so, since you people already know, so I just see what all things you know. You know about computer system components, correct? So I will skip this actually. You may also know about this, correct? How the CPU central processing unit looks like. There is a there is a memory unit, there is arithmetic unit and the control unit that you already know. So and you also know about the storage system. There is a primary storage and secondary storage. You people know, correct? What is primary storage and secondary storage? Volatile memory and non-volatile memory. You people knows or not? You don't know.
Yes, sir.
Okay, so there is this is all we know. So in the core of the CPU, if you look at the core of the CPU, so there is if this is called a processor, so usually processor, or you can call this is a core of the CPU, the processing unit, you can say. So central CPU is a central processing unit, correct? And there is something called a control unit. So this control unit is the one which will be controlling whole operations of these processors. So control units will manage everything. So control unit is the one who will be managing the CPU, running the CPU, also running the multiple other, interacting with the multiple other devices like input, output, memory control, all those things. It will be done by this one actually. And in the processing thing, there is a registers and there is a combinational logics. This combinational logics are some kind of a logic which performs some kind of activities. This combination logics is a combination of, see, combination logic, you sequential logic, combination, all people you know what they will do. Now they will do the small operations. Those operations may be arithmetic operation, there may be logical operations. They do all these functionalities necessary for running the processor. So I don't go in depth, but like that is what it will be there. And the main thing where you will be doing, these are the registers. So depending on what computer your CPU architecture are looking for, sometimes it will call R1, R2, R3, R4 kind of register names. Some places it will be called AX, BX, CX, DX. Intel follow that. ARM follows R1, R2, R3, R4. So it's like depending on the things. And this are called general purpose registers. I hope you already know. And there is arithmetic logic in it, and this is spatial registers. So instruction registers, program counter, and process state registers. You know, correct? Any you people knows these things, correct? Yes or no?
Yes, sir.
So instruction, see why I'm only mentioning these are the very three important registers actually. Apart must like a special, like if you wanted to understand how program behaves, these are the three things you should be knowing it actually. And about the RAM, and there is a RAM addresses, so that you will be knowing. And and another thing is actually like in the computers all data are stored, whether it is data, whether it is a text, whether anything, like if you are trying to do image, text, everything, it has to be stored in the computer, it has to be stored in the binary. Is that clear? So finally the computer only sees the binary numbers. For you, if you are accessing a text file, for you may be accessing ppt file, For you may be accessing image, for you accessing a video, for you may be accessing audio files, but everything which is stored, means like which is stored or computed or operated or everything is in binary. Is that clear? So computer only sees in binary forms. Is this clear?
Yes, sir.
Okay. So now binary system, I'm not interested to go through. I think you already know the binary system, how to convert decimal to binary, binary to the hexadecimal, all those things you already know. So I'm not interested. You people knows, correct? By the,
Yes, sir.
okay. So this and ASCII tables, like why I'm trying to say ASCII tables, because I say every text, every information will be stored in the binary. So this ASCII table is actually how to convert the non-numerical kind of, like some kind of a information, text or numbers or digits, something has to be converted into some kind of equivalent kind of a number. So why this ASCII table comes actually, because see, this is a standardization. Like whenever there is a necessary of a standardization, it's like, no, for example, if you are using ARM and if ARM processor converts something different, and if you are using PowerPC, then it is storing something, or different operating system, different computers. If everybody is behaving differently, then there is no uniformity. Means like if I have to do something, then I have to be very specific to certain CPU, certain operating system, then only it will work. No. So if we have to be make everything is that is called what is called, it works inter they don't have a dependency, like, so it works across all platform operating systems, everything. Means like there is some kind of a standardization teams. Those standardization teams is actually, this is how you should be doing. So ASCII table is designed by a standardization team. So the every character or something will be converted into some kind of a decimal value, and that is the format they have given. So this everybody has to follow. So that is how the, because of that reason only we can operate. Like, so you don't feel any difference in working on the smartphone, working on laptop, working on MacBook, working on some, all those things. Like, so that is all because one or other standardization team will be there. They will be standardizing how you will be operating. Is it clear?
Yes, sir.
So this is already we know, so I don't go here. Okay, one main question. So now I hope you know why computer stores only in binary. Why not decimal? Why not trinary? Why not octal? Anybody have any guess why computer stores only in binary? Okay, so how the computer is manufactured? Using what? What is the basic component of a computer?
CPU.
CPU, mouse, keyboard.
No. So that is a components. So if we have to manufacture a computer, like if you want to design a CPU, what is the basic component you will be using? You know VHDL, no? So what is the basic component you will be using to design a computer? Okay. Other way around. So how we will be designing CPU? What you will be using to design a CPU? You will be using something, correct? What is that? Okay, other way around. So you okay, if I have to do a adder, if I have to do a adder circuit, so how we will be designing this adder circuit? You know VHDL, no? You studied VHDL, adder, subtractor, all those things, correct? So what is the basic logic you will be using?
Basic gates, sir.
Basic gates. Okay, basic gates are used to do that. What about these gates? Is gates are designed by, if I have to design a gate, so what we will be using? Gates. So they will be using transistor to create a gates, correct?
Operators.
Uh, uh, gate design. Let me show that gate design. If I look for AND gate design, this is how it looks like, correct? AND gate design. This is how it looks like, AND gate design, correct? Yes or no?
Yes, sir.
So what is this actually? What is this? These are
Transistors.
transistor, correct? So it's like what I'm trying to say is, no, everything which is designed, you wanted to design a CPU, everything, the basic component is a transistor. So, and if somebody says actually 8 nanometers, 10 nanometers, 16 nanometer and something, no, so that is what actually the difference between one transistor is like, how to pack these two transistor, how much near we can squeeze. So if it is 10 nanometer, means like gap should be 10 nanometer. If 6 nanometer, means like gap should be 6 nanometer. So that is what, how it's like everything is like anything, like if you say memory, it will be designed by transistor, computer ALU designed by transistor, everything control, every basic component of the CPU design is a transistor. Is it clear?
Yes, sir.
Yes, sir.
Okay, what is a transistor? How many states transistor can hold? Transistor can be on, transistor can be off, correct? Yes or no?
Yes, sir.
So on only it will hold on state and off state. So what is that actually? On state is one, off state is one. That is the reason. So if transistor can hold, if the basic component of a CPU can hold multiple states, then it can hold out. Like so, since it holds only two states, so that is on and off state. So everything is designed by that. So basic component which can hold is a 0 and 1. So that is the reason it is a binary. It stores only binary. Is it clear?
Yes, sir.
Yes, sir.
So finally, it is a transistor and transistor something. Assume that if you design a transistor which will hold a three things, then you will be using qubits. Like so, you may be heard about quantum computing. You heard about people heard about quantum computing, correct? Yes or no?
Yes, sir.
So quantum computing is actually it can hold 3 bits. So one component, basic component can hold 3 bits. So if one component can hold 3 bits, means like how many states it will be having? See now currently it can hold only 1 bit, correct? Currently on and off it can hold. So only 1 bit. Now what we are saying actually in quantum computing, the basic components holds 3 bits, means like 8 states. You got it? It can hold 8 states. So it is 2 to the power of 3. Means like that is the power, means like it is enhanced to that level actually. That is quantum computing. In quantum computing is all about how you will be making sure that the basic component, so what I'm trying to say is actually will be holding. Means like it is all about your system, like this is a classic computing. Classic computing is it only holds 0 and 1. In quantum or like a qubits, they will call it qubits, it can hold multiple states. So it can hold multiple intermediate kind of states. So how many are there? If it is holding only 3 states, then that is how it is holding about 8 states, or like so depending on how many states it holds, that is that much powerful it will be. It's fine. And it may be using binary. If it is holding 8 bits, means like it won't be using binary, it will be using octal decimal. Fine. So if it is holding 4 states, then it will be not using the binary, it will be using quadinary, something like 4 thing. If it is using if it's holding 8 statements, like that you will be using octal system. Is it clear? But right now we don't have actually, like right now the production of the quantum computing is not there, so we will not be studying. So right now we'll assume that like everything will be working is in the binary system. Is it clear?
Yes, sir.
But in quantum computing comes, this will be there. And what is exactly the thing is actually same chip ID, so same size of the chip, the computation will be becoming 3x or 4x. So the speed will become something that like to the power of 3, correct, 8 times. So same system, like if you are using computing, it's like what happens actually, computation capacity is increasing multifold. See why we will why we are going from one CPU to dual CPU, four core CPUs, 8 core CPUs. Intention is actually increase the competition, correct? What is the objective of making 8 core system is increase the competition. Competition is like calculations has to be made faster. 8 core means like one they will be 8 instruction can be executed simultaneously. Means like the speed of execution increases. So now 8 core is in compound computing, 1 core only do the 8 core kind of equal. I'm not exactly saying same thing, but I'm just giving analogy. So one CPU can do the work of 8 core kind of things actually. So means like, so now if it is already have a 8 core means like how much competition it should have. So that is how the quantum computing is gaining lot of traction, and they can solve very complex kind of things. Like for example, this is what I'm using, this what is called a GPU. So it is taking almost like to run this program, it is taking almost all 1 day. So this would have been speed up further. So things will be there. And now like weather forecasting or like a lot of complex earthquake prediction or like so a lot more complex kind of scenarios can be computed much more faster actually. So that is how the people will gain the advantage of these new technologies. But right now quantum computing is in the research stage, not in the manufacturing stage. It's like in the end using stage actually. So any questions here? Any questions on these things? Okay, binary system already you know, bits, bytes, kilobytes, megabytes, gigabytes, terabytes, exabyte, all those things you already know. So big endian and little endian also you know. You people know, correct?
Yes, sir.
Yes, sir.
So these are the basic thing which later on like maybe we'll be using it actually. Another thing is actually arithmetic, like ALU I said, no? When I said ALU we have two components. One is the arithmetic model, another is a logic model. So it will have two models. And this mux, you know what is the mux means, like mux will be combining things. Like so all these are like your electronics thing only. So operander 1, operander 2, and opcode. Opcode is the opcode means like the command what you want to do. Operander 1 and operander 2 is the data. So means like if you are trying to say A add and B. So if you are trying to say add A comma B, so this is the operand and this is the operators, fine. So you will be trying to execute that, fine. This is opcode, so operators, fine. So you will be executing things actually. So now, so arithmetic operations, add, subtract, you all is know. So addition, arithmetic addition, subtraction, multiplication, and division. So these are the basic arithmetic operators supported by the ALU. And logic, the full adder, these logic gates you already know, full adder, half adder, all those things will be there. So how exactly it looks like actually, this is the two values you will be getting, and there is a carry in. So you will be getting the result plus carry out. So what is a carry in means, like this is a carry in. How the carry in, so carry in come from some other thing also, but like a carry, see in this case actually how you will add actually 5 plus 9 14, 4 is here, 1 is carry, so then something like that, like so now. So and this is 4 only. If it is 14, then again the carry will come, so that is carry out. So that is how it will be. Just I'm trying to give similarity in the carry in, carry out, ABC results. Fine. Any questions here? Anything? Not understood? I'm just going fast because you people already know. The first year, if you are in the first year, then I would have explained all those things. So any questions here?
No, sir.
No, sir.
Okay. Okay. In the logical, when I said logical, like logical model, so it will be executing these kind of things like so OR, NOR, NAND, AND, NAND, XOR, XNOR, and there is a buffer and there is a NOT. These are the logical operators it will be having. So you know already truth table of AND, OR, XOR, NOR or something. So these gates. So the thing. So now A plus B is sum and carry. This also addition of two binary numbers. Also you know subtraction of binary numbers. Also you know Bitwise, okay. So these are the things. And what is the logical operators? Logical operators also does some kind of a bitwise operators. So you know what is a bitwise operators?
Yes, sir.
So there is a logical operators and there is a bitwise operator. Bitwise means like you will be I will explain again. In the Python also will come that we'll get that Python whenever we're discussing operators. So logical operator means like if it is a true and a true, logical operator will give the result is true. So when you say in the bitwise thing, actually, like if you say some number, so number, and if you say bitwise thing, actually, and another number. So even so now what it will convert into the binary. This also will convert into binary, and the bit by bit it does operation and that give the results. That is a bitwise thing. So we'll discuss that in detail when we are discussing in the Python bitwise operator. So only the difference between the logical and bitwise, actually, like bitwise will operate on the bit by bit, logical things. This I will revisit, actually, like I'm not saying that, like this segment I will revisit whenever I'm explaining the Python thing. So any questions here? Like I think this is all I have to explain along with the code. So any questions here? Okay. So till this extent. So I will explain these when I'm explaining Python operators. So till this extent, any questions? It's all fine, correct?
Yes, sir.
Okay. So let us come to the Python thing. So now little and big endian is done. So we completed. Okay. So we were here expression. Okay. So we were object code. So we were till this extent. Okay, this is done. So objects in Python we discussed, actually. Now the next thing, so we discussed about the basic foundations of Python. The next thing is very important things are expression, operators, and operands. So now what is we will be learning is actually what is meant by expression, what is meant by operator, what is meant by operand. So now if you see here, actually a plus b, so a plus b whole thing is called expression, or even if is equal to this also expression. Let me say that, actually if I say c is equal to a plus b, this whole thing is called expression. Fine. So now where was that, actually? So this whole thing is called expression. It can be like this, or it can be like this, it can be like this, or it can be like this, anything. These are all called expressions, correct? Now in that there are two things are there. So there are, say if you see here, actually, so there are something like this, actually. These are all of one kind, these are all one kind. So these are all variables, there are variables, correct? So there is a hello, and there are something called other things. So these variables, like what we are using, so these are all called operands and this is called operators. This is a very, very basic thing. So there is a operand and there is the operators. So when we say expression, operators, and operand, so this is called expression. There is operators and there is a operands. So what kind of expressions, what kind of operators, what kind of operands are supported by Python is what we are looking. So each different programming language supports a different expressions, operators, and operands. So now what we are interested is actually what is supported by the Python. Python language supports what kind of operators, what kind of expressions. That is what we are trying to study. Any questions on expression, operator, and operand? Okay. So the operators, so what is supported by Python is arithmetic operator, assignment operator, comparison operator, logical operator, bitwise operator, identity operator, membership operators. So we'll go one by one. These are the 7 basic operators which is supported by, because when we are trying to discuss about this expression is built using operators plus operands. Operands is the variables, correct? So all the things, but first if you wanted to study how to build an expression, so first we should be studying what kind of operators supported by the Python, and then using that operators how to build the expression is that what we'll be studying later on. Any questions here? Okay, so let us first start with the Python basic of operators like arithmetic or rational something. No? So first we'll look into arithmetic operators. So there are there are two things are there. One is actually addition. So let me show you that like addition. So if I have to say A is so anything, so A is equal to 10, B is equal to same thing. No? So I'm trying to do the same thing, A plus B. And so this is a arithmetic addition actually, which I'm trying to do. So let me. So these are very basic things. So let me do the basic thing because it's simple to do. So star multiplication. So division. So any questions here? I think this is very simple to understand. Correct? Any question? Okay. So, and these operators will need specific operands. So something may work on all. And what are the different data types are there in the Python? So there is a int, there is a float, there is a string, and there is a complex number in number actually, and there is a bool. We discussed this, correct? There is a bool, and there is a none type. It's like special type. So special type, and there are so many other classes are there, collection data types actually, like list, set, tuple. We'll discuss that actually. So we're not discussed tuple, dictionary. So like that, so many data types are there. So now, why I am discussing this now? So this some operators works on different kind of data types. So what is that operand? Operand will have such specific data types, correct? So what we discuss actually, there is a operator and there is operand. Operand may be anything, correct? So I'm not said actually what is operand. So when I say operand can be anything. Where was it actually? When I say operand can be anything, correct? So this operand can be anything. So this operand a may be integer, a may be float, a may be string, a may be list. Is fine, correct? So it can be any type, correct? Yes or no?
Yes, sir.
So now what we need to know is actually which operator works with which kind of data types. So that is the one thing we should be doing. So that we will discuss actually. Now integer is fine, floating also it will work. Now we'll see that like for the string. So now for integer and float, it is same thing. No, so you will work on that. So now what about Boolean? So if I do Boolean thing, how it will happen? So something that like a is equal to true, whether it works or not. So this is what you see. What I'm trying to say now. So when I'm saying that operator, you try to see these all the things are possible or not. Like so, see basically actually everybody will understand this. So this is, if you only learn this much, you are equivalent to all normal guys. So if you wanted to be above the normal guys, then you should be exploring for a little bit further beyond them actually. So you start exploring that. Is it, see why this is I'm trying to show only a few things, and remaining you experiment and as a task of assignments. It is nothing wrong whether it works or not. You should be trying to check. So it is like that, like A I have done, B is actually, if I do A plus B, what happens? So it is coming true. So how, why, and all those things we'll discuss. So so this is how, okay, this is coming true, and this 2 is equal to true also. Anything greater than 0 is considered as a true. So value is considered as a true. So true plus true is also true. So this is giving result true. Is it clear?
Yes.
Yes.
Okay. Now let us try with the string. So now I am trying to say, So let me A is equal to Satish. A is equal to numbers only. Okay, let me do this way. Now A plus B. So now what is happening? So it does a string concatenation. This is a string, this is a string, and it is adding. Adding means like plus. What is the plus of working here? Plus is working as a string concatenation. So adding to strings. So here string is working as a string concatenation. Here what is this? This is doing so addition. So the Boolean values are converted into the numbers, and that number is adding and then giving the results. Is it clear? So if it was working as an add or, so then it would have given only true. But here the Boolean values are converted into a number and the numbers are added. So that is the reason it is true. Any questions here? So like that, complex number you try and other kind of things like so list and set and tuple I have not discussed. So you will discuss that whenever we discuss actually we can try that. So any question here? Any question on the operators?
No, sir.
So now we looked about addition. So we looked about add. So we looked about subtract. We looked about multiplication. We looked about division. So these are the things we have looked into. So now next thing is actually there are few more things are there. So what is that? That there is a star and there is a percentage and there is something like a 2/. So what is that actually? So star, you know what is a power, correct? So power 2 to the power of 3, 2 something that like correct. You know that 2 to the power of 3. How should we do it actually? So 2 star 3. So this star is actually 1 star is multiplication, 2 star is power. 2 star is a power thing. You know what is power, correct? So fine. So then what is the percent? This is a modulus. So this is called a modulus. So what is the modulus? Okay, if you don't know the modulus, let me explain that actually. So now if it is a 4 divided by 3, so what is the result actually? There is 1 and there is a 1 remainder, correct? Or 1 by 3 we can do. This is how we can do, correct? Yes or no?
Yes, sir.
So now this is the integer portion and this is a remainder actually. Fine. Modulus will give this reminder. Modulus, when I say 4 modulus 3, we will be getting the result this one. So let us try that actually. See, there is nothing called a theoretical. We'll try experiment because Python is very easy. No? So A is equal to 4, B is equal to 3. So A modulus, sorry, A modulus B. So this is what we are getting. So this is what we discussed. Any question here? Okay, you may be confused actually like why it is okay, let me do that like 5 by 3. What is a 5 by 3? What would be the result? 5 modulus 3. What would be the result? Anyone? What is a 5 by 5 modulus 3? Anyone can explain what would be the result? You understood modulus? Okay, let me explain again. See, if it is 7 by 3, what will be the result? Usually it will be 2 here, 1 by 3. So how this 2? 3 into 2 is equal to 6. So next 1 extra. So that is 1 by 3. Fine. So it's like 6 plus 1. So if I divide by this 2, 3, this is divided by 3. So that is what is giving 2 and 1. It's like modulus is actually I will keep on dividing the number with the 3 till I get a number which is not divisible by 3. And that number is a reminder. Whatever I'm getting a reminder, that reminder I'm trying to give as a result of the modulus. Is that clear? Do you understood the modulus?
Yes, sir.
Okay, what would be the result of this actually? Like one example, where was it? Okay. If I give 5 by 3, what 5 modulus 3, what would be the result? Result can be, see when I, yeah, what is the result?
0.5, 0.53,
0.053.
0.53.
This is the result. I'm saying modulus. Okay. Okay, let me explain again. I think you not understood the modulus. Okay, how should I get the modulus? Let me do that. So for example, if I say 7 modulus 3, so what is 7 1 ja 3 1 ja 3, 3 2 ja 6, correct? So 2, so 6. So then what is left out? Can I divide 1 by 3? No, correct? So this is a reminder. This is a reminder, correct? So now how should I write this actually? This I would have written 2 1 by 3, correct? So in the fraction number, forget. This is a division, correct? Or else this is a reminder. So this is the modulus. So for example, take another example. 16 by 3. So 16 by 3, or like 117 by 3. So sounds like, so 117. So now how should I do? So first I should be dividing this, correct? So 3 1 the 3, 3 2 6, 3 3 the 9. So this is a 3. So this is a 9. So now what happens actually? So 2 and 7. So 3 9s are 27. So what is the remainder? Remainder is 0. So now 117 modulus 3. If I say modulus 3, the result will be 0 because the remainder is 0. Right? So now you take another one, 54, 55. So then what would be the thing actually? 3 1 ja 3. So 2 comes 2 4 2 5. So 3 8 ja 24. So 1 left out. So 55 modulus 3. 55 modulus 3 means like what will be getting? That we will be getting 3. Sorry, 1. This one. So understood what is the modulus? Do you understood what is modulus?
Yes, sir.
Yes.
So now can you explain this? Like, so I am writing what would be the result here? A modulus B, what would be the result? What would be the result?
Yes, sir.
What is that?
No, sir.
Okay, good. So that is, now you understood what is the modulus, fine. So now what is the next thing? So we understood power. So we understood modulus. And what is the next one? This is called floor division or integer division. So floor division and integer division means like, okay, let me explain that again. So now assume that like this 7, I am dividing. This is division by 3. What would be the output? Output will be 2 plus, so 2 say 2 plus something. So 1 by 3. So means like see how it will be divided. So if you divide by the number, so 3 2 is 6. So that is 6 is done. So 1 is left. 1 divided by 3 is actually 0.33. So this is a result, something, correct? So 7 divided by 3, what we will be getting is 3. Yes or no? So, okay,
Yes, sir.
so 7
Divided
division
by
3. So you will get
2.3.
so 2.33. So 2.33 what you will be getting. This is a normal division. This is called normal division. That is one. What is a floor division? When I say floor division, so it will remove off all the decimal portion from that. So only the integer portion it will give. So when I say 7//3, then it will give 2. Fine. I'm discarding the the floating things. Whatever the integer portion, only I am trying to display there. Is that clear? Do you understood what is a floor division?
Yes, sir.
Okay, let us try that actually. Doing that. So, okay. I'm copying here. Now what I'm trying to do. So floor division. So what would be the result here? What would be the result?
1, sir.
Okay. So fine, good. So this modulus will give reminder and this gives a floor. If I have to reconstruct this, how should I reconstruct? If I have to reconstruct the number using the modulus and the floor, how should I do? Okay, so for example, somebody says, find out the number. So question will be something like find the number for which if we divide by 3, it will give. So if you divide, so if you do floor divide by 3, it will give 1. And if we do modulus, it will give 2. So find that number is a question. This question is understood. Do you understand the question? So if I do floor divide with 3, it will give 1. If I do modulus for that number, I am trying to ask you that like what is the value of A? I am giving value of B. I am saying that like if I do modulus, it will give 2. If I do floor division, will go. So this is how you should start building your logics. How should I do? Now assume that floor division is equal to, what is that floor division? Floor division is 1 and mod values is equal to 2. So that number B is equal to, what is the modulus? What is the floor division? FL into that number. What is the number? Division number. Okay, now I'll say this is C. This is C. B is equal to 3. Correct? B is equal to 3. That I am trying to give. So now how should I do? FL into B plus, what is that actually? What I'll be getting, the remainder. Remainder is actually modulus plus mod. So this is what it will give C. Is it correct? Is this equation is correct? Is this logic is correct?
Yes, sir.
So this is called expression. So by using these things, and I'm trying to build an expression to do some kind of result. So that is what I'm trying to say here. Any questions here? So that I got back the value 5. So I use the same thing. So whatever like, so this is how you should start building simple logics. So fine. So any questions here? So any questions on this floor division, modulus, power, and this ends the arithmetic operators. So arithmetic operators, these are the common arithmetic operators. So fine. So any questions? Okay. If there is no question, we'll go for the assignment operators. What are the assignment operators? Slash and equal, percentage, modulus and equal, floor division and equal, and star and equal. So this is okay. The normal assignment is already we know. So this already we know assignment operator is equal to. So one is the equal to. So equal to we already know. So apart from this, additional thing is actually plus and equal to, minus and equal to. So star and equal to, division and equal to, modulus and equal to, something like that. So what is this actually? So it is something that like, let me explain that actually one by one. So now plus and equal to, let us go to the plus and equal to. Are you following correct? You guys are following now?
Yes, sir.
Yes,
So
sir. Yes, sir.
Yeah, any question?
No, sir.
Okay, so now A is equal to A plus 5. This is a equation. This is a equation, correct? So assume that like this is a equation. This equation can be simplified something like this: A plus equal to 5. So fine. So this value, this is same, then that will be here, and this plus will come here, and this equal come, this is 5. So it's like this and this equation are both. It is as good as like, so when I say A plus equal to 5, means what I am trying to say is equal to A is equal to A plus 5. This is what I'm trying to say. This is a reducing the shorter kind of like, so simplified or like easiest way to write actually. So this, instead of writing again the variable here, so this is how we will be writing. Any questions here? Do you understood? Okay, let us try that, executing that. So now, so let me see that like now we are looking for assignment operators, correct? Assignment operators. So for what we looked into, so okay, let me do that. So far we looked into arithmetic operators. Operators. Okay, fine. So in assignment operators, what I'm trying to say is equal to A is equal to 5. Now A is equal to A plus 5. So print A. And now what I will be doing actually, I will be doing exactly same, but not like this. Plus 5. So print A. So both should be giving the same result. Is it clear?
Yes, sir.
So same thing. If it is minus here, so minus here. Multiply here, multiply here. Division here, it's like whatever you are trying to, any operators can work into. So any questions here? So that you can explore yourself. So this is division, this is 4, this is star, anything. So it's the same. So you try, take one example and try to do. So that is the assignment for you people to explore. Any questions here? So the operators are coming there. So only one condition you should be remembering. What is that actually? It should be same. So this and this should be same. Then only you can do it. Fine. Okay. So do you have any questions here? Or you want me to explain any one of these? Understood? Yes or no?
Yes, sir.
Okay. So we'll move to the next one. What is called comparison operators. So what is a comparison operators? So what is a comparison? We compare, no? So how you are there, it's like we compare between two individuals, two qualities or something. And comparison also something similar to. And one more thing you should remember, no? So I told you here also in the initially, all these operators, now I'm just working on the only integer types. You can also explore with other data types. That is also another assignment. It works or not. Fine. I'm only explaining because I cannot explain all types, all because like it is too much thing to be explained in something. You can try out with all other data types. That is also another assignments you will work on to. And that you will be all these things I will be submitting. You will be saying that like I tried with all other type of things, whether it works or it doesn't work. You will be giving that notion saying that okay, this plus operates works on these is data types, it doesn't work on these is data types. So this minus works on these data types, this doesn't work on these data types. So you should be executing and displaying, and that sheet you should be submitting as an assignment. Is it clear?
Okay, sir.
So because when you try, then only you will learn. So if you are just listening and going, you won't be learning. So that is the reason I'm giving assignments, because if you just listen and go, then you will forget. So that is I don't want actually. Fine. Okay. So now we move to the comparison operators. So what is the comparison operators? So the name itself says no. So and most of these programming, if you know understand the basic English language thing, so you understand this meaning. Comparison operators. So any question? Okay, in this comparison operators, what all the operators supported? So greater than, less than, equal to, this is two, equal to, correct, equal to, and not equal to. So what is that actually? So there is a difference between these two. So this is actually assignment, this is assignment. So if I say this and this, actually it is saying equal to, equal to, this is assignment. Is this clear? This is assignment. So most of the tricky question they wanted to check, actually they will check on these two. So they will say compare, and but they purposefully they will give only one, means like it becomes assignment. They say assignments, purposefully they will give these two. It's like it is a comparative. So that you should be remembering. So this is it clear? Assignment and equal to. So this is equal to. So what is equal to? So if there is one operator here, if operand here, there is one operand. So it will check actually this operand and this operand both are same or not. So means like, for example, if I say A is equal to 5 and B is equal to 10, B is equal to 10. If I'm trying to check A equal to B, so what would be the result? Is both are equal or not equal? So what would be the result? Are both 5 and 10 are equal?
No, sir.
So if I say A equal to B, then it will be giving say that like it is not. So it will give the result Boolean value, that is false. False means like they are not equal. If I make both equal, okay, let me do in another place. If I make both equal, it will give result true. Fine. The comparison operators will give the result in a Boolean fashion. Correct? Any questions here? So okay, we tried one. So now in this case, not equal to will give true. So let me do that, not equal to. No, I will go down here. In this case, the not equal to will give the true result because they are not equal. But in this case, not equal to will give, not equal to give the false because they are equal. It's fine. So not equal to, and this greater than or less than you already know. So let us see that also will try. So now, so this also will give the result in what is called. So now I'm trying to do greater than. So now if it is A is greater than B is true, then it will true, but A is lesser than B, so it is not true. Other way around, it should be true. Other way around, it should be true. So fine. Other way around, it should be true. Fine. So now, so next, any questions here so far? The next thing is actually, let us do one more thing. Now, if I do something like this, what would be the result?
False, sir.
False?
Yes, sir.
Why it is false?
A is not equal to B. Sir, A is less than B. A is, but A is not equal to B, so it gives false.
Sir, A is less than B.
Okay, so that A is less than B, correct? That is what I'm looking for, no? So now A is equal to 5, B is equal to 10. Now what I'm saying is equal to A, this B. What is this means actually? So A equal to, so what I'm trying to, whether this is less than B or equal to, correct? So it's correct. All this is A is always less than B, correct? That is what is happening. So let us do other way around. So you take this example. So this is false, correct? Now, if I do something like this, so another thing you remember. So I am not giving equal after that operator. I am giving equal right of that actually, not left of that. See, if I give something like this, it will give error. So this doesn't exist. This doesn't exist. So this will give an error. See, correct? This doesn't exist. Yes. So what I'm trying to give, I'm trying to give other side. So what would be the result?
False.
Correct. So now you understood, no? So that is what it is there. Fine.
Yes.
So now we'll look into this is comparison operators are done. So now logical operators. So any questions, like any doubts so far? Any doubts so far? Okay. So now we'll do logical operators. Logical operators. We know what is the logical operators, correct? We already know that we came here, correct? So between the logical operators, we already looked into logical gates, logical symbols, or nor, and all those things actually. Among all those things, what is supported by Python? Python may support everything or Python may not support everything, correct? So what all the things are supported in Python? That is what we need to look into. And what is supported in the Python, based on that, can I build every other things? Is that is the problem statement we will be getting. Is this clear? Okay, first let us see that like what all things are supported. So Python supports and, or, and not. So using and, or, and not, can I build any all other kind of things? Or is exactly same, nor is already there, and is not already there. And is there, NAND can be done using, can we see, or is there, and is there, not is there, or NAND not is given. So and not, I will give NAND, or and not, I will give NOR. Is it clear? Can I do?
Yes, sir.
So that is what. So now XOR and XNOR. So I think XOR and XNOR has to be there into that. Okay, fine. XOR is also there. This is a XOR. So this is XOR thing operator. So bitwise in bitwise it is there. So it's like all the basic essential things are there in that. We'll discuss one by one. So now what we are discussing actually, and. So this here and. So one more and, or, and nor. So what is this and, nor, and nor? These are logical things, not the bitwise things. So logical things means like, let me do that actually. If I say A is equal to 5, same example why I'm taking, you will be getting, you will be able to understand how things works actually. So now C is equal to A and B. So now then I'm trying to print the value of the C. So either you can use something do here, or else you can say that like print C. Both are fine. So it's fine. So if it some interpreter doesn't support, you should be always say print C. So fine. So then you will be saying print C. Now you tell me that like A and B I did, but what I got? Okay, let me do other way, another one also. So now I am trying to do a is equal to true, b is equal to true. Now I'm trying to do this. So what I'm getting? So why this and why this? Anyone can answer? Okay, what is and? Okay, you know and get, correct? What is and? Truth table of and. True and true gives true. True and false gives false. False and true gives false.
False.
False and false gives false, correct?
False. Yes, sir.
So this is and. Exactly same. This is exactly same what I'm trying to do. It's fine. So true and true will use. Like let me try give that example. True and true is giving true. So let me do other true and false. So true and false also will give. So true and false. What it is trying to give? False. Other way around also is used, correct? So I no need to do other way around. So false and false also I will try to do. Fine. So is exactly and, correct? Now this we understood. This we already know, correct? Now why is like this? So this is what they will ask you tricky questions, no, in Python. If they wanted to ask, no, they won't be asking this. This is very generic thing. This is very basic. If you are not able to answer, means like you don't understood the and operator. This is very basic, but they wanted to check your knowledge. They will be checking this kind of questions. So what is this actually? Anyone? Okay. So how this operates? No, this operates something different. That is what is the thing. So now you are saying a is equal to 5. 5 is true, correct? Anything value greater than 0 is true. So b is 10. So 10 is also greater than 0. So that's also true. Now true and true. So result is true. Now, but so what you are given is an integer. So output should also be integer. So shall I take this or shall I take this? So it is a thing. So that let me try other way around also. Let me show you that like other way around also. Here, if I do reverse it actually, this I make B, this I make A. So if I execute actually, see what is that you are trying to get? Understood the logic? So here it is A, sorry, A and B. So B is 5, A is 10. So A and B. So whatever is the last element is trying to take it. Simple thing. So both are true. Instead of result is true, so it has to give the result in terms of integer again. So what is that it is trying to do? So both, so this is integer converting into integer converted into boolean, and then the result is boolean, and this boolean has to be converted back into the integer, because that is how you are given the input. So whatever is the last it understood, it will take that one actually. And this is dependent on interpreter. In Google Colab, this is how it will work. In some other places, because that is completely dependent on interpreter. So that is value result is dependent on interpreter. If something, I can take any value. So somebody is writing, I can display A also value also, B also, because both are true. So instead of saying selecting one, so this interpreter takes the last value. Is it clear? Do you understood this? So 10 is also true, 5 is also true, result is true. Instead of just it has to give the integer value. So both are true, it will pick one. Which one it will pick? It will pick the last whatever it appeared. Is it fine?
Yes, sir.
So these are the tricky questions. These are not the simple questions actually. These are the tricky questions. So they may be asking actually, like if you are wanted to check how deeper you know Python. So they will check that kind of things actually. So how deeper you know Python. So the last year is D is 15. So I got the 15. So fine. So this is not level 1. It is level 2, level 3 kind of the problem. So you should be able to. And this is also not level 1. So this is also like whether you understood the modulus and division, floor division. So they wanted to check actually. So this is like a basic asking question. This is how they will check actually whether you know those things perfectly or not. So fine. So any questions here? So we did we did and okay, only and I did, no. Okay, let me do or also. Same thing, no. Or is also same thing. Take I'm not doing everything there are because one explain, no. So rest all is also same thing, like I'm trying to do or here. So or also that's one. So now what is the difference between or and? So R is taking the first element, not the last element. Because how it works, no, let me tell you. The logic also don't for no need to remember I've had something. So okay. The logic also, see, you should not be having anything. Let me see. Now how and operates actually. So if I say true, if I first element is true, then and result is dependent on second element, correct? Yes or no?
Yes, sir.
So if first element is false and value results on, there is it doesn't go further, correct? It only false, correct? If first is a false.
Yes, sir.
So that is how it will display the result. So let me to go for the R. So because it depends on the thing, so whatever it depends on, that result displaying. So take about the R case. In the R case, if first is true, do you think that it will go further? Even if you are getting something, but do you think that it will look into this second? True only, no? Yes or no?
Yes, sir.
So that is what the first element will be displayed. So this is how, this is a smart kind of interpretation. So when if a true with anything is a true or anything is a true. So true is done. No need to look into further. False and anything false I know. So no need to look into further. So if it is a true and then it will look into the second element because the result will depend on the second element. So that is how the second element will be the result. So you understood now the logic. So that is how it will interpret and that is how the result will be displayed. And what about not? You already know what is not, correct? Okay, let me show the not also. So for wanted to display not. See, this works with normal thing also, like or. I'm not saying that like or doesn't work here. So if I say true, if I say false, so it works true only because first element only. So if it is A, no, not. So not, fine. And one more thing, no. So no need to hat also, like capital or small. So you should say that like color change has to happen, fine. So if it is a true, then result will be false. If it is a false, okay, let me do that also. So any questions here? Any question here? Any questions on these operators? Logical operators. So what we'll do now, we'll take 5 minutes break. So after that, we'll discuss the other thing. Is it fine? Because already we'll take 5 minutes break.
Okay, sir.
And after the break, we'll discuss the bitwise operators, identify operators, membership operators, and we'll do some exercise also. And I will give few more assignments to you. It's fine. Okay, we'll take 5 minutes break.
Okay, sir.
So we look into
13 minus 8.
logical operator.
You have to
The
take
next
a
thing is actually like we look into bitwise operator. So we discuss a little bit about the bitwise operator. So how exactly works here. So let me explain one bitwise operator. Like let me see that actually. So 0 0 0, if it is and 0 and 1, this already we know. So now how exactly bitwise operator works. So let us take a is equal to 10, b is equal to 7. So what is the 10 actually? Like let us take that number here. So now assume that like a is equal to 10, b is equal to 7, b is equal to 7. If we take it actually, b is equal to 7, and what we are looking is actually a and b. So then c is equal to a and b, and I am trying to print the value of c. This is a program, correct? So now my voice is audible, correct? People.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So now what I will bitwise now, in whenever we are trying to bitwise in logical, like this 10 is true or 7 is true. That is how I'll calculate in the logical. If it is true, true. So true and true, true. That is how. But in bitwise, this 10 will be converted into 1010. You know how to convert this 1010, correct? So I'm not explaining how to convert 1010. So then 7 will be converted to 111. Is this understood in the binary form? Fine. So understood this one? 10 becomes 1010, 7 becomes 111. Now what I will be doing? I will be doing first this bitwise operator. 0 and 1, what is that result? 0 and 1 result is 0.
0.
1 and 1 result is
1.
1. 0
0.
and 1 is 0. 1 and 1 is 1. So the
1.
result is this one. What is this actually? This is equal to 10. Correct? So that is what I should be getting. Is that clear? So let us try that actually. I should be getting the same thing. So bitwise operator. So now a is equal to 10, b is equal to 7, c is equal to a and b. What is the operator? This is single and. So this is single and. So and operator. So now I am trying to print the result of c. So I should be getting value this one. It was, but now what I am getting actually, I'm getting value 2. 1 minute. Sorry. Yeah. I should be getting okay. So there was some mistake. What was that mistake actually? There was some mistake. What was the mistake? Here it will be 0. Should be 0. This is a mistake. Yes or no?
Yes, sir.
This is a mistake. We because if there is no digit is there, then it is 0 is there.
Sir,
Yeah. Tell me.
only 3 ones are there now.
That's what, like when 3 ones are there, there is no digit is there, means like it has to take 0 values. Correct? See how see how we will be writing now. If I have to do bitwise operator. Let me explain that actually. That is a mistake we have done. Okay, now if it is a that like if it is a 1001, if I have to do bitwise operator for this one, what is the value here? What is it? It has to some value, correct? Then only I can do bitwise operator. Yes or no?
Yes, sir.
So what is the value? See,
0, 0.
0 can be any. This is same. No, I'm not changing the value, correct?
Yes, sir.
So that is what. So this is what we forgot there. Okay, now what is the value will be? What is this 1101? 11 is 12. This is 13.
13.
So this is 2. So now if I do that actually, this is
Sir, 3, sir.
Is it
Below
3?
3.
Below 3?
No, sir. The value is the 1001.
It is 3, correct. This is 3. So
Yes, sir.
this is what is 1.
One.
So now if we try to do the same thing with this actually, like we'll get the same result. Let me do the same thing, cut and paste. So now one is 13, another is 3. The result would be what we are supposed to get is the 1. Where was that actually? The result is 1. So you understood bitwise AND operator?
Yes, sir.
So now we'll do bitwise OR. So what is bitwise OR? So same thing. Let us take another example. So you give me some number, 2-digit number. A is equal to, shall I take 25? Okay, B is equal to something that like 6. Now, what is the conversion here? 20. How should I convert actually? 25. So 16 plus 8 is 24, correct? Plus 1. So 1, 8 is 001, 16 is this one, correct?
Yes, sir.
So what is 6 actually? 6 is 110. Now I'm trying to do OR. What I'm trying to do OR, bitwise OR. So here I'm taking 0, here also I'm taking 0. What is the R value will come? 101, 01, 1, 10001, 1, 101,
1.
01.
1.
So what is the number this one? So that is what you give me the what is the digit number. So by that time I will write here. It was R. What is that value? So 25, 6. Bitwise R is this mark. Bitwise, this is bitwise AND this is bitwise OR operator. So what is the value? So 31. So this is 31, correct? So how should I get this 31? So how many? 1, 2, 3, 4, 5. So I should be doing 6. 2 to the power of 6 is what? So this is 5, correct? 1, 2, 3, 4, 5. 2 to the power of 5, how much? 2 to the power of 4, 16.
16.
2 to the
32.
power of 32, correct? So 32 minus 1, correct? So 2 to the power of 5 means like how much actually? 1, 1, 2, 3, 4, 5, correct? How should I represent 2 to the 5? Okay, let me do that. So now 2 to the power of 0 means like 1, there is nothing is there. 2 to the power of 1. 1 means like 1, then 1 0. This number of 0. So 2 to the power of 2 means 1, 2 zeros. 2 to the power of 5 means 1, 1, 2, 3, 4, 5 zeros. Correct? So now what we are looking for? 5 ones. So means like this minus 1 is 5 ones, correct? Yes or no?
Yes, sir.
So that is what 32 minus 1 is 31. So fine. So any questions here? Bitwise OR and bitwise AND.
No, sir.
No,
next-
sir.
The next, yeah. Any question? You want me to Repeat. Understood or not understood?
Yes, sir. I got it.
Okay. So the next one is the bitwise XOR. Fine. So what is XOR? So XOR is so 0 1. What will be the result? 1 0 1 1 0 0. What is XOR actually? Complementary, correct? What is XOR? You know XOR or not?
Yes, sir.
Yes.
So bitwise not, bitwise XOR. So 0. See, there is a difference, then 1. So there is a same, that is 0. That is XOR, correct? If both are same, then value is result is 0. If they both are complementary each other, value is equal to 1. So that is XOR. Fine. Any question here? Is this is clear, correct? This is also called differentiator. So this bitwise not I have not done actually. Bitwise, okay. Any questions here? Okay. So let us do the XOR here. What is the XOR? So now take one example, any number. So let us take one number and then we will do the bitwise XOR. So take the same number. What is that number actually? A is equal to 25. It is very easy to, why I am taking same now, it is instead of converting everything in a binary again, I am just using it actually. What is the 25 actually? How is it actually? 16, 8, and 001. This is the 25, correct? And the 6 is 110. So then if nothing is there, it is 0 here, nothing is there, 0 is here. Now I'm doing XOR. This is XOR symbol bitwise. So 1 and 0, 1, correct? 0 1 1 0 1 1 1 0 1 1 0 1. Yes or no?
Yes, sir.
Sir.
So what will be the result? What is this value? Already we know, correct? That is 31. Same thing. Let me do XOR. Cap. Any questions here?
No, sir.
No, sir.
Okay. So then another one, I think it is not there. One's complement. Okay. There is bitwise not also there. Let me do that also. So there is something that like A is equal to 25 and C is equal to A. C, print C. So this is also there, but in this I am not mentioned here. So this is what is getting minus 26. So what is this actually? It is one's complement. So what exactly is one's complement? You looked into one's complement, correct? You guys knows what is one's complement, correct? Yes or no?
Yes, sir.
So what is the one's complement? What is one's complement? See. Okay. Let me ask the question here.
All one, sir.
Okay. Now, if you say A is equal to 10, so 10 becomes actually 1 1 0 1 0. So what is one's complement of this?
2.
This
Zero.
is 1
0
1.
0.
But something also will be here, no? These are all initially zeros. They all becomes 1. So if it is a 8 bits, there are 8 bits are there. So now only we looked into 4 bits. Remaining bits are all zeros, so that also has to be complemented. And if first bit is, if first bit is 1, that is a sign bit. That means actually it will become negative. If it is 0, that is a positive. So 1 means sign bit, you know, correct? What is sign bit? Studied sign bit. The maximum MSP. You know what is a LSP and MSP?
Yes, sir.
So integer, like what happens actually in the thing, like if it is 8-bit or if it is 32-bit, whatever it may be, the how much bit integer will store. So what is that actually, like the last MSP bit, 1 bit is actually this bit. No, this is actually this is MSP bit, and this will become the sign bit, the last element. If it is 32, so 0, and this is 31. 31 bit is a sign bit, and 30th is the MSP bit. This is a sign. If it has 1, then it is negative. If it is 0, then it is positive. Fine. Sign bit 1 means negative, 0 means positive. So now what happens actually, like when we convert something like this, so that effect will come. So now what is happening is actually 825. So 825 is I converted bitwise 1. So how the bitwise 1 is operating here? So let us do one's complement of what I'm trying to do, correct? So now what I will be doing, so 25 is actually 11001, correct? Yes or no? This is 25. Yes or no?
Yes, sir.
So now here lot of zeros will be there. All this will be zeros. How many bits are there? This is all zeros. Assume that like this is 5, 6, 7, 8. Oh, assume that like only 8 bit. So this is only 8 bit. Fine. This is how it will be. Now, so what happens actually? This is a sign bit. So now what I will be doing? So it will make this is 1. So this becomes 1. So now rest all will be becoming 1 1 0 0 1 1 0. Right? But now this is the negative, and plus I will be adding 1. So I will be adding 1 to this actually. So I should be adding see now if I add 1, what is this value actually? This value is too much, too higher number, and this is sign bit, correct? So now how this will be calculated actually, like this will be, this is a 25. So it makes this number, so this number as a this number, it will add 1 to it. So the one, see in this calculations, what happens actually, whatever the number you are trying to give, this number, it will add 1 number to it, and it will say that like the number will become negative. So the one's complement, when I take it actually, so whatever the number, it will add 1. So why this will add 1, or why this will add 1 and 1, or this actually is the how this not operator works into. So any number, it will add the 1 number to that, and then adds the sign is equal to 21. Let me design take another one example. So let us take this like 20. So it will add 1 to it and add the negative sign there. This is how it will work. So but it is exactly same as the way we execute is a one's complement. So this is exactly where the one's complement, it will complement that, means like so this is how the it works, like so it will add 1 and then adds the negative to the number. Is it clear? Is it understood how this works actually?
Yes, sir.
Yes, sir.
See any number, let us do one more example. So now if I give 31, if I give 31 or what 120, if I get 120, so what would be the result here? So plus 1 and negative sign. So why this, why doesn't this way? See, actually it has to work something like this, correct? So actually it has to work something. See, this is exactly complement, correct? This is exactly complement plus 1 if you add it actually. So then it will become 1 1 1 and 0 0 1 and 1 and 1. So this is a negative number, no? So what is this negative value? So this negative value will be again complemented. So this is again complemented. So negative sign is takes actually, and value will be again complemented. Again complemented means like 0 0, then 1 1 0 0. This is how it will become. So again it will be complemented plus added 1. So we see how the negative number is represented there. Negative number in binary. It is little bit like a negative number in binary. It will be stored in 2's complement. Is it clear how the negative numbers are stored in binary? Okay, let me explain that actually. Like if your negative numbers are there, if negative numbers are there, that negative numbers are stored, whatever the numbers is, the negative numbers are stored in the 2's complement way. What is the 2's complement way? What is 2's complement thing? 2's complement is actually the number will be complemented plus adding 1 is a 2's complement. 1's complement is actually this number will be this one. So it's like will be flipping the number is a 1 complement, 2's complement. Next one, what happens actually? If there is a negative bit is set actually, then that digit value has to be transferred back. Means like it will be again it takes a 2's complement. That it's like the 1 will take the minus. So that is why I'm forget about all the logic behind that. You just remember that any number it will add 1 and the negative sign. So but exactly how it works in the computer is actually like, let me explain that one example. 1 0 1 0. So if it is takes a complement, what happens actually? 1 bit is set here and then value becomes 0 1 0 1, but this is negative. So the value when I'm trying to display, again it will take complement of that. So 1 1 0 1 0 plus adds 1. This is 2's complement. So then and takes this sign from here. So what happens actually? 1 0 1 1. So with minus sign. So it's like it takes 1 complement, stores the number, and when I'm trying to display, well, that is how it will 2's complement of that number with the negative sign is what it will be displaying. But instead of all those things, you assume that like the not bitwise not works. How is actually whatever the number you are giving, add 1 value to that and sign add the negative sign there. Is it clear?
Yes, sir.
So that is forget, because it becomes too much complex to remember taking 1's complement and again taking the 2's complement, all those things you forget actually. You just remember that any number we add 1 and the negative sign. That is how the not operates. So in the here actually like or and is there, even not also, bitwise not also there. Any questions here?
No, sir.
Okay. So the okay, one more, like the trickiest question they will be asking is actually combination of, like, let me do one more little bit like a complex thing. So now if I give something like this, so A is equal to 10, B is equal to 20, and C is equal to A and B, or A. So what would be the result? So here one question will come. So you should be what is if something like multiple operators are there. So how should we solve the problem? Here there is one operator, there is second operator of two different type. So then what is the thing first it will strike to you is actually what is the precedence? You heard about what is the precedence? Precedence of operator. That you should be knowing that precedence of operator, but I have not covered that actually. But whenever I cover, then I will solve that actually. Or else like I will go back to the precedence of operator. This is a precedence of operator. So first priority is actually first priority is member access. Member access I have not explained. I will explain what is the member access means. Member access is something that like I told you know. So if for example if it is a is integer, so a dot, then whatever the operations you are trying to do, so bit count or bit length. So this is called member operations. So they have the highest priority. They have the highest priority. So they have the highest priority actually. So member operators will have a highest priority and it will work first actually. In this scenario, I will explain that later on because I need to explain the bitwise operator. But like this is how you should be trying to do all the permutation combination, and you will be trying just like I'm explaining one thing is like you should not be trying only one. So we'll hold this question later on. So I will solve this later on when I explain the membership function thing. So any questions here? So I don't want to jump there. So any questions so far? See, one thing I will go start with basic and then I will start increasing the level. So it is not that like you should be just learning the basics. So you should start thinking and going on upper and upper. That is what is my way of learning thing. So it is every time like you won't be getting the same basic level. So it will be little bit like a complex and complex that you go. So any questions so far? So till this you understood, correct?
Yes.
Okay. The next thing is actually like there were two more operators are there. I will explain that actually. Then we will go back to the other thing, and then I will come back the combination of that. So combination I will come a little bit later on. So one more is actually this is right shift. One is right shift. One is the left shift. So how should we remember which is right shift and left shift? So the direction you should not remember like by heart actually which symbol is right shift or right. So what is this direction showing? See, this is the direction point, correct? So which this is how it is showing, correct? If two symbols are something like this is how it is showing, correct? So this is what is right, correct? So if it is showing something like this, so this is way it is showing. So this is the left. So this is the left shift, this is the right shift. Is it clear?
Yes, sir.
So how to what is meant by right shift and left shift? So what is the right shift and left shift? It's like you are trying to shift. Like so, for example, if you take a is equal to 10. Now I am trying to do right shift. So sorry, left shift by 2. So what is that means actually like 10 is converted into 0 1 0. So now I wanted to shift into 2. So what is that actually like this guy? Okay, this is one position, this is another 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 position. So assume that like nothing is there, these are all 0. So this guy will be shifted here 2 bits, so it will skip here. So means like new value will come. So 0, so 0. So new value will come. So this guy will come here. So that is 0. This guy will come here. That is 1. This guy will come here. That is 0. This guy will come into 1. So what is our result? 1 0. Sorry. This is fine. 1 0 1 0 1 0 0 0. So it's like you know that what is that shift, correct? You know what is a shift means? So shifting the bits. Shifting. So forget about what is the right or left. So whenever I'm saying shifting, so you are shifting. So when you say shifting something, so you are moving position, or you are shifting your position. So one left side or one right side, like so when you are sitting and together, so shift one portion, one pushing one by, correct? No, either left side or right side. Is that clear? Shift. What is so now if I'm trying to do shift right means like I'm shifting the right side. So now how you should be remembering is actually think this way. So take another thing. So now something that like you are playing the musical chair or something that like there is, so certain number of bits are there, so certain number of chairs are there. So assume that like we have around 8. We assume that like we have around 8 chairs are there, correct? Now you are sitting here, one guy is sitting here, so something that like these people are sitting here, something. Now if I say shift left, so this guy will sit here, this guy will shift here, this guy will shift here, and this guy will shift here. So fine. So after some time, so they will fall down. Assume that like that knot doesn't come. If I say right shift, actually, this guy will shift here, this guy will shift here, so this guy will shift here, so this guy will shift here. So something like that, like two shifting. Means like if they are falling out, so and the new numbers come into, so whichever the other numbers are there, that is what you should be remembering. Let us do that like here, shift right. So now take that A is equal to 10. So how should I do actually? C is equal to A left shift 2 bits. So this is the bit number, how many times you should be shifting. So now, and I'm trying to print the value. So what is the value? Value is 40. So what we got actually here? So what is this value? So this is 16, correct? Huh? How much is it actually? And what is this actually? 32. So A is equal to, what is this? What is this number? So if I shift 2 bits actually, then what I'm getting is 40. Any questions here? Is 40 correct? This is 40 or not? How much is this number? Hello, you guys are there or not?
Yes, sir.
Yes, sir.
Binary to decimal, let me do. Calculator. What is this number? 1010 1010 130. No, it's correct. This is what we got, correct? So if I shift 2 bits here, this is what I got, correct? Sir, no. And I converted into decimal, this 40. That is what we got here, correct?
Yes, sir.
Understood?
Yes, sir.
Okay, let us do for the left shift. So if I do left shift, what I will be getting? Sorry, right shift. So if I do right shift, what I will be getting? So now take the same example. So 1010. If I do 2 right shift, means like how it will be shifted. So now this 0 will drop off, and this 1 also will be dropped off. And what happens actually? This 0 will come here, and this 1 will come here. So next all numbers is 00. So that this 0 will come here, this 0 will come here. So means like what is that number? What is the output? Output is what? This is output, correct? So let me explain it properly. Okay, is it understood? Now let me do again. 1010. So shift to 2. So now what is that actually? Like this is the position, 4 position. So and this is the end point, correct? So now here nothing is there. So this 0 has to shift to 2 position here. So it's like this is dropped off. This guy shifted here. That is also dropped off. So now this guy is shifted here. So this will come here. And this guy shifted here. This will come here. correct? This is how it is shift, no? 1 0 1 0. So this is out of the thing. Now the new guys are 0 added. So all these new things will be always 0, correct? 0 comes. This is what is output. And what is this actually? Value is 2. Yes or no?
Yes, sir.
Are you following me or not following me? Understood that this understood
Yes.
right, left shift and right shift. So if I do that one, actually I should be able to get the value 2. Fine. So in terms, if I have to say right shift and left shift, actually were bitwise shifting. So if, for example, if I do take this example, actually, this, see what happens actually if you go out of this. So this is the boundary, like 0 bit. No, if you go beyond that, that values will be discarded, and all the new values whatever we are inserting is always replaced by zeros. And this side also news, if you wanted to add the new value, it will be 0. From here also, if you are adding new values, that will be 0. So that is how it will work. Fine. So or else, like if you wanted to simply say, that like right shift. So this is the best way to understand. So for example, if somebody asks you to do right shift, so don't do all those complex kind of scenarios if you are not comfortable. So that is why I'm trying to explain, because you should know the theory behind that. So if you feel that like it is too much complex actually, so you should not remember the simplest way, but that is actually theory behind how it works. So now if I have to do right shift this one, so this one I have to right shift 3 bits, right shift 3 bits. How should I do? Simplest way is actually discard these 3 bits, and this 1 0 1, add 3 new bits. So what is the value here? Is 5. So what is this value? So this is 5, this is 8. So 5 plus 8, this is 8 plus 16 plus 32 plus 32. So 32 plus 8 is 40, 45. So 45, if I write left shift by 3, so what is that I will be getting? Assume that like A is equal to 45, correct? A is equal to 45. C is equal to A, how much left right shift by 3. So C value should be, what is the value? What I got here? What is the value I got here? 5. So what is the value I got? 5. Is it clear?
Yes, sir.
Yes, sir.
So now, okay, now same logic. If I had to do left shift, so left shift also simplest. The theory already explained. Simplest way is actually this way. Okay. So now assume that like 1 0 1 1 1 0. So if left shift actually, this is left, say that like left shift 3 I'm doing, no? So then what is the value actually? Value becomes 1 0 0 1 1 0 0 0 0. Here also it will drop off when it reaches a 32-bit, it's like beyond 32-bit if it goes. So beyond 30, if it is 64-bit register, think the integer, then beyond 64-bit, then it will drop off. But whatever number we are giving a simple small number, no, so automatically you think that like a small number, you just add 3 digits. So this is see till this extent, this is what is the result. Is it fine? Because this is not 32-bit, 1 2 3 4 5 6 7 8 9 bit only, so it won't drop off. So it will drop off when the number of bits go beyond 32. So simply you should add 3 bits there. Is it clear? So how should I do?
Yes.
So simple thing, like, so what is this value? Okay, let us try this actually. What is the value? This is 6, this is 8 32 64. So 64 plus no, this is 6, no, this is 8 16 32. Okay, 32 plus 16 plus 6. So what is that actually? So 32 plus 6 is 38 48 54, no, 54. So this number is 54, correct? 54. And what is this number? Okay, let me do 1010 So this bitwise now it is very difficult to like 1 1 1 1 0 1 1 0, correct? 1 1 0 1 1 0, then 3 zeros. 1 1 0 1 1 0 1 2 3 zeros. This is what it will convert. So now this 3 digits are not there. What is the value? This 54. Okay, 54. If I do left shift, you should be able to get that value. So fine. So 50, 54, no? Yeah, 54. So now 54, I'm trying to do left shift 3. Fine. So I should be able to get that value. What was that value? Let me again do here zeros. I'm just adding 3 zeros, correct? 1 2 3 zeros. So that is what 432. So that is what we got, 432. Is it clear? So
Yes, sir.
if you're doing right,
Yes, sir.
you just add 3. So this is the simplest way to remember. See, if you are doing right, you just add 3. If you are doing sorry, if you are doing left, you add just 3. If you are doing right, you just drop it. Actually, that is the best way to remember right shift and left shift. Any questions here? So this is the simplest way. I will share this. Actually, you can go through, see how it will work. So this will come here, this will come here, this will come here. This is the simplest way to know the logic. So any questions here so far? Shift left, shift right. Any question? The one more thing you should be remember. Yeah. One more thing you should be remembering here is actually what exactly that means. So for example, understanding what is necessary here is actually assume that like if A is equal to 10. So now I am trying to do one shift. So A into 1 right shift I'm doing. Means like if you say the output result, actually what is the output? It will be 20, because I'm multiplying with the 2, 1 2. And if I do 2 shift, actually means like I'm multiplying 2 to the power of 2, means like 4. So I'm multiplying with the 4. So 10 into 4 is 40. So if I'm trying to do 3 shift, actually, so what it indicates, actually I am multiplying with 2 to the power of 3. What is 2 to the power of 3? Is 8, correct? So I'm multiplying with the 8. So then 10 becomes, means like if I do right shift, I am multiplying whatever the number is there, that number to the power of that number. Like, so for example, if I'm trying to do right shift by 1, means like 2 to the power of 1. So if I'm trying to do right shift by 2, means like I'm multiplying that number by 2 to the power of 2. So I'm doing right shift by 3, means like I'm multiplying that number by 2 to the power of 3. Is it clear? That is
Yes,
what
sir.
that is what we got. So 2 to the power of 3 is 8. So 8 I'm multiplying to 10. So 10 I'm multiplying with 8 is 80. That is what I'm getting result. So opposite of that is the division. So I will be trying to divide that, actually. So let us see that, actually. If I'm trying to do left shift by 1, sorry, so right shift by 1. If I'm doing right shift by 1, so I'm dividing that number. So 2 to the power of 2. So 10 by 2 is 5. So if I'm I'm doing another one. So by 2. So what is actually divided by 2 to the power of 4. So if I 10 divided by 2 to the power of 4, so that is what I am getting. And this one, this division is actually, what is that actually? 2 to the power of 4. If I divide, what is this division? Is not actual binary division. It is a floor division. You understood what is a floor division, no? So 10 to the power, see, if I do 10 to the power, what is that? Okay, let me again explain. 10 by 2, what is that actually? 10 by 4. If you do normal division, it will be 2.5, correct? This is normal division, correct? Yes or no?
Yes, sir.
So now if I do floor division, what would be the result?
2.
2. So that is what we get here. 10 to the 2 to the power of 4 is 2 to the power of 2 is 4. So 10 divided by 4, that is a floor division, not the binary division, because decimal division not possible. All binary doesn't have decimal, correct? So decimal means like it will store in binary, so all number. So there is a way to store binary in decimal number in using binary, but that is all different. So this is all you can think, remember is actually this is a floor division. Is it clear? This
Yes,
is a
sir.
floor. So this is a floor division. I will write here floor division. So what is that actually? 2 to the 2 to the power of 2. So here what is actually here floor division 2 to the power of 1. Correct? So is it clear? So let me, is that understood?
Yes, sir.
Yes, sir.
So now what are the things you understood? Right shift, left shift, bitwise XOR and OR. So this is all we understood. So now two more things are there. What is called identity operator and membership operator. So what is this identity operator and membership operator? So what is the identity? When we say that, like, what is your identity? What you will say? Oh, I am so and so, so that is my correct. No, you will say my identity. So means like identity is actually, it is saying that like, okay, is this person is X identity, Y, this is a professional guy, or this guy is a sports guy, or is this person is a film star. What is your identity? Means like I am trying to compare what you are. So that is what is. So when I say, are you a professor? Are you a teacher? Are you a film actor? Are you, what is your identity? Identity means like I am trying to assume that like so many different characteristics are there, professionals are there. I am trying to check, are you this guy? Are you this guy? Are you this guy? Is, it's like whether he is a actor or whether he or she, whatever it may be, she is a doctor. So that is what I'm trying to identity thing also. Same thing. Whenever I'm saying that, like, I'm trying to just giving analogy to remember that thing actually. So identity also something similar to that, identity operators. So identity operators, there are two operators are there. One is and not is. So there are two things are there. One is. So if you see it actually is not, is not. So whether he is a doctor or whether he is not a doctor, whether he is a engineer, whether he is not an engineer, or whether he is a sports star, whether he is not a sports star. Is it clear? Is and is not is the identity operators. So what it will do? It will say yes or it will say no. Correct? Whether he is actor, if he is that guy is actor, then you will say yes. Whether he is a doctor, if that guy is doctor, you will say yes. If not, you will say no. So fine. So one is, another is not. Is not means like negative of that actually. Isn't he doctor? Is not his doctor? Yes, like that way you are asking that question. So why I'm trying to say, just to remember that. So how should it happen actually? Like assume that like if x is equal to 5, then if I operate x is 5. So is 5, x is 5 or not? If it is there, it will give the true result. If it is not, like let me do other one, I think. So I'm saying x is equal to 6. So I'm trying to compare. Is x is 5? No, it is not. So it is a false. So now, is it understood? So is not.
Yes.
Is not will give the true picture because it is not correct. So it is true. So that is identity metric. So why we will be using that actually? Because for some complex things, I'm trying to compare these things. So here it is very easy to compare, but a lot more things are there. Like then you will be trying to compare. That will be very easy to find out whether this is same or not same actually. So for that purpose, we will be saying. But like whenever we will discuss some programs actually, we'll discuss actually how it will be used. Because in complex, because numbers is very easy. So a string and all more things, no, when you are trying to compare, then this will be much more easier actually. So it's fine. Is that identity operators? Any questions here?
No, sir.
Okay, so that is done. Then there is two more operators are there. So what are the operators actually? Membership operators. What is a membership actually? So whether are you member of a club? You say if you are member of a club, you will say yes. If you are not member of a club, you will say no. So membership operators actually like will be used whether when there is a collection data, like whenever I'm trying to explain a collection data, I will explain actually whether you are part of that group or not. So are you part of that group? If you are yes, you will say yes. If you are not, you are not saying that. Like, so for example, to explain that, I will explain with one list actually. So list I am not explain right now, but like I will just create a list actually, then I will explain membership operator. So I assume that like this is a list. So the list is actually A is equal to a list of like something like 1, 2, 3, 4. Assume this is a list actually, like you just assume this is how I'm trying to create, but I will explain later on how to create a list. But right now, just assume that like this is a list. So now I'm trying to say if one in A is one is in A, yes or no? That one guy one is there part of the list. If it is there, it will give true. So it is there. Let me do same thing. 8 is not there, correct? So if it is 8, I'm trying to check, it will say that like it is not there in the list or the false. So members is actually whether this person is there in that group or not. To check in, not in. Fine. Is it understood?
Yes, sir.
Now this will work out true if not in. So he is not in that group actually. That is not like, so he is not in A. So it will give true. So 8 is not in this list. So it will give true. So that is the membership functions. So membership operators. So identity operators, membership operators, bitwise operator, logical operator. It's like all these operators I have done. Any questions here? So the any questions? If there is no questions, like two more slides are there, I will complete actually. So one is about operator precedence. As I said, no? So one has a more preference compared to other one. So if you are having multiple operators, like so this case, what I was trying to say here. So where was that actually? This one. So let me select this. Okay, so now in this case, there is a AND operator, there is a OR operator, bitwise OR and AND. So whether I should be first calculating this, or whether I should be calculating first this, and then I should be result and this. So how should I go about? So now there are two things are there. Let me explain that actually. So now if you say A and B, sorry, A and B. So now R. So R something, what is that value? This is R, RA, okay. RA. RA. So now, so whether I should be working this first or whether I should be working this first. So how should I define? So this is one operator and this is one operator. So which one is the first preference? So I should be operating whether I should be doing first this and then next this actually, or whether I should be doing first or this one. What happens actually, like let me do that actually. If I do A and B first actually, then what happens actually, this will result into something like assume the C. Then C or A I will be doing the second stage. It's the first stage and the second stage. Or other way around, if I'm doing other way around, assume that like A same thing, like then what happens actually, B or A will be done first, and then what happens actually, then second stage is equal to A and that's the resultant. Assume that this is C, then this is what I'm trying to do, this way or this way. Any question? Yeah. Any question? Any question?
No, sir.
So this, how should we decide? There is operator precedence. What is the operator precedence? So is it visible now? Let me make it more bigger. So now first preference is actually membership access. So means like any expression dot one, this will be executed first. And the second preference is actually method function. Method function is like you are calling a function with passing a parameter, that will be executed second. So if you're calling a function and passing that actually function or method, or something, or like splitting and contact. I will explain this actually. Splitting or subscription or slicing. When I'm explaining list actually, when I explain the function methods actually, I will explain function calling or splitting the expression. It will be, these two things will be called second preference. Like function calling means like, I am saying that like length we used to do no type is a function. For type I was saying type A. So this is a function calling with the parameter A. So function or slicing. So that is the second priority. The third priority is exponential. Star is the third priority. Fourth priority is unary operators. What is that? Like plus, equal to, minus, equal to, all this what we discussed, no, plus sign something. So that is a unary operators is a fourth priority. Fifth priority is actually multiplication, division, floor division, and modulus. These are the fifth priority. Addition will be the next priority. Bitwise shift is the next priority, and bitwise and is next priority. Bitwise or XOR and XOR R. So this is a priority. Now what we are discussing is, we are discussing this R, this and we are discussing this R. R is higher priority compared to and. Is it clear? So according to this actually, this will be executed first. So this will be executed first because bitwise R has higher priority compared to and. So this will be executed and result we will see, and A and C will be calculated second. Is it clear? Are you able to understand? Hello?
Yes, sir.
Yes, sir.
Yeah, so this is how the operators, like this you have to by heart it actually, because the, or else like you can there is, see, a few things are very easy to remember, but a few things you should be trying to by heart it actually. This is the this is specific to Python. It may not be same for C++. For every programming language they have a operator precedence, but this operators and the precedence is completely for the Python language. This is the order it will be there. So yeah, usually like no, usually this member access functions will be always higher, exponential always higher. After exponential, unary operator, most of the programming language, and multiplication, division, and addition. After that operator only the bitwise will come, and comparison will come, then logical will come, and last is conditional and assignment. Always last will be conditional and assignments. So that is how the logic will be there. See, across the almost all programming language, but here also it is same, but sometimes there may be change. Why conditional will be the last but one? Because if conditional is first, no. So for example, I'm going out of things. So for example, if I'm trying to do if A greater than B, this if is a conditional. If it has to execute it first, means like no, first it has to execute, then only if is no. So that is how it will be there. So conditional will be all those if or all logic, all will be if and else condition, everything will be the last actually. So then assignment will be always last most of the time, then the logical, then the comparison, then the bitwise, then addition, subtraction, unary, exponential, functional. This is how the order will be. But if you remember 2 or 3 times actually, this is how you will be remembering the order of these opera precedence. Any questions here? So I am done here. I am done the session. So let me do one last example. If we have to do swap two numbers, how should we swap two numbers? So one example I'm trying to explain. If I want to swap two numbers, like assume that like A is equal to 5 and B is equal to 10. How to swap two numbers? In Python, it's much more easier. If I have to swap, so B comma A equal to A comma B. So then you print actually. So print A comma and B. So automatically it will go to swap actually. So using assignment operator. So fine. So A is 10. So earlier A is equal to 5, correct? So now A is equal to 10, B is equal to 5. Or else like let me print 2 times. Something like that. So is it understood? Swapping two numbers.
Sorry, sir.
Fine. So this is how. S- Fine. So shall we end here?
Yes, sir.
So hope you understood the operators and what is the assignment. So I have done this. I will share you. I will upload. I have done with only the integer. You should be trying with other types and you should try with all permutation combinations there. How much you keep trying, that much good you will become. And when you master this, you should not be get confused with anything. So especially most important thing what you will be trying is actually bitwise operators. Usually bitwise is little bit tricky. Bitwise and logical combinations is the next one you should be looking into, because identity operators, membership operator doesn't have anything. So bitwise and logical combination is what you should be working, practicing a lot, because there only lot more confusions will be there, and that you should be trying. And but other thing also you can try out. So fine. So shall we end here?
Yes, sir. Thank you, sir.
Thank you. Thank you for patience and listening. So we'll see next time.